We'll now continue our discussion of section 9.3, looking at the hyperbola. Let's review, before we get started, our definitions and our formulas. Remember that for the standard form of a hyperbola, we have two versions of the formula. One version begins with the x value, and that one has your parabolas opening one to the left and one to the right. The other formula begins with the y value, in which case you have a parabola that opens up and a parabola that opens down. Remember that in either case, your foci are represented by your c value, and your vertices are represented by your a value. And you have the formula c squared is equal to a squared plus b squared to relate your different values. So let's look at an example. Given the hyperbola, and we have our equation, we want to look at graphing that hyperbola and then noting the asymptotes for the graph. Now, in order to talk about graphing this hyperbola and being able to pull off any information from our equation needs to be in standard form. So remember that to take something in general form, as we see on the slide, and write it in standard form, we need to complete the square. So I'm going to begin by grouping like terms together. So I'm going to group the x's together. So I'm going to write the negative 16x squared and the positive 96x. I'm going to leave myself a little bit of room, and then I'm going to write my y terms together. So 9y squared plus 18y, and I'm going to leave the 279 on the other side. Remember that in order to complete the square, you must have a 1 as your coefficient in front of your squared terms. And so because we have this negative 16 instead, we want to start by factoring that negative 16 to the front. So when I take a negative 16 out of a negative 16x squared, I'm going to be left with just x squared. When I take a negative 16 out of a 96x, that's going to give me 6x, or actually negative 6x. And then we're going to do the same thing for the y's. So we need a 1 in front of the y squared, so we'll need to factor the 9 to the front. Taking a 9 out of a 9y squared leaves me with the y squared. Taking a 9 out of an 18y leaves me a 2y. And then remember that the idea behind completing the square is that you're going to take your middle term, which will be negative 6 for the x's. You're going to multiply that by 1/2 and square the result. So we know that half of negative 6 is negative 3. And negative 3 squared is 9. And so I'm going to add 9 in the space that I left. And then I'm going to balance it on the other side. But we're going to keep in mind that this 9 is being acted upon by this negative 16. So it's not that I've added 9 to the left-hand side, but I've actually added a negative 144. And so when I come in and balance, I'm going to do the same thing on the other side. So again, negative 16 times 9 is going to be negative 144. Okay, let's do it for the y's. So we're going to take our middle term, which is 2. We're going to multiply that times 1/2 and square. And so we know that half of 2 is 1, and 1 squared is 1. So I'm going to add the 1 in here. And then what do I need to add on the other side to balance it? This 1 is being acted on by the 9, so 9 times 1 is going to give me 9. Okay, so now what should happen is that we should be able to come in and factor this x quadratic, and we should be able to factor the y quadratic. And then on the right-hand side, we have 279 minus 144 plus 9 gives me a positive 144. Okay, so let's factor. First times first is going to have to be x times x To make a 9, it's going to have to be 3 and 3. Now remember, these parentheses that you come up with have to be identical. And so they both need to have a subtraction so that you can make a negative 6x in the middle. For the y's, we're going to start with a y and a y to make a y squared. To make a 1, we'll need 1 times 1. And since there are no negatives anywhere in the original, we're going to keep these positive. So I have negative 16 x minus 3 squared plus 9 y plus 1 squared is equal to 144. Remember that in standard form for your hyperbola, you need it equal to 1. And so the way to make this equal to 1 is to divide it by 144, but if you divide one term by that number, you need to divide all terms by that number. So when we reduce 16 over 144, we get negative 1 over 9. When we reduce 9 over 144, we get 1 over 16. And 144 over 144 is equal to 1. Now, because I'm leading with my subtraction here, I'm going to turn this around. I'm going to put the y term first. And so my standard form is going to look like y plus 1 squared over 16 minus x minus 3 squared over 9 is equal to 1. And this will be the standard form for my hyperbola. Now, the next thing that we need to do is we need to determine basically the turn of the hyperbola, the center, and the vertices. So let's get started with some of that. I'm going to make some room here. Because my formula leads with the y, I know that the parabolas, I have one that opens up and one that opens down. I also know that my center point if I look in my x parenthesis, I see a minus 3, so that's going to be a positive 3x value. When I look in my y parenthesis, I see a plus 1, so that's going to be a negative 1. So I have a center point at 3, negative 1. And I know that I have a parabola that opens up and one that opens down. Okay, so once that's determined, let's go ahead and figure out our a and our b values. Our a value is going to come from the 16. Remember, this is a squared. And our b value is going to come from the 9. So we know that a is equal to 4 and b is equal to 3. And so let's go ahead and do our vertices. We know that the vertices play off of the a value. So I can go ahead and mark those off. So I am going to come up 4 units. From the center. So this is 1, 2, 3, 4. Okay, so we have a vertex point here. That's going to be the point 3. And up 1, 2, up 3. And then we're going to come from the center down 4. 1, 2, 3, 4. That's going to be the point 3, negative 5. Okay, so we can go ahead and do our foci as well. Remember that our a, b, and c are related by this formula. C squared is equal to a squared plus b squared. So I can say c squared is equal to a squared plus b squared. So my a squared is 4. My b is going to be 3. So I have 16 plus 9. C squared would equal 25, and C would equal 5. And so then we can come up 5 units from our vertex, from our center. So 1, 2, 3, 4 puts me on the vertex, and one more. We've got our focus sitting here. So our foci points we would have at 3, 4. And then we'll come down one more here. And that would be at the point 3, negative 6. Now, the next thing that we need to do is actually find our equation for our asymptotes. So I'm going to go back to my formula for the asymptotes. And we're going to use this one because our y comes first in our equation. And so our formula looks like y minus k is equal to a over b times x minus h, and then the negative version of that. Okay, so I'm going to go back to my problem and let's jot that down. And let's plug in our values. So in our y parenthesis, remember that it's y plus 1. So that's going to be the y minus k part. The a over b will be 4 over 3. And our x parenthesis was x minus 3. And so here are the equations for our asymptotes. Now, what I want to show you is kind of a shortcut to actually doing your graph. In the previous example, we actually plotted some points on the asymptotes and connected them based on those points. There is a different method that we can use that is perhaps a little bit easier to go about drawing those asymptotes. Okay, and I'm going to show you, and we'll go ahead and show you the graph that the book does, and then we'll talk about how that graph is created. All right, so if you see what has been done is they have basically came in and they plotted the 2 vertex points, which we could do. And then notice that they've drawn sort of a rectangle here in the middle. Now, what they have essentially done is they have taken the A value and the B value from the problem. All right, so our A value was 4 and our B value was 3. Now, remember that the A is going to define the vertex points. So you essentially are going to start at your center, which is here, and you're going to count up 4. 1, 2, 3, 4. That takes you to that vertex, and then you're going to count down 4. 1, 2, 3, 4, and that puts you on that vertex. And you are going to draw a dotted line that goes through that vertex point. Now, for the other side of that rectangle, you're going to use the B value. So our B value is going to be 3. And so what we're going to do is we're going to count across in both directions 3 from the center. So 1, 2, 3, and 1, 2, 3. And we're going to use those 2 points as the other side of our rectangle. And so I can then say, okay, I'm going to come down like this and form that rectangle. So that rectangle is going to have a length of A going up and A going down, and a width of B going across in each direction. Now, the point of drawing the rectangle is that the asymptotes will go through the corners of that rectangle. So once that rectangle is drawn, then I automatically know that my asymptotes are going to run like the diagonals on that rectangle. And so I can draw those asymptotes through the diagonals of the rectangles without having to plot specific points to figure out where those asymptotes are. And remember that once you have your asymptotes drawn, that defines the width on the individual parabolas and allows you to draw a graph.